Okay, so for the 3D vectors, first you got to kind of learn to draw them, okay? So let's say that I gave you the vector, I don't know, u equals 2, 3, 4. 2, 3, 4. How do you draw that? Well, first you construct a diagonal line like this along one of your 30-degree lines, and then you connect. That's like going to be like your y-axis actually. And then you draw another one. Sorry, that got moved. Didn't want that. Then you draw another one going the other way. Let's use black. And then you can actually pick whichever one you want to be your x-axis. It doesn't really matter. I'm going to always choose this one to be my x-axis and the other to be my y-axis. Okay? And I usually choose the right side of each to be the positive direction. So I don't usually even put arrowheads on the negative direction. So this direction would be negative x, and this direction would be negative y. So right now you're like, what am I doing? Why are you drawing your x going down the page? Well, it's supposed to look kind of 3D. Okay? Maybe I can convince you better if I shrink this a little bit. Give me 1 second. Let me shrink this down. Imagine that this was sitting on a table, a desk. Here's the desk. Okay, here's the legs of the desk. So this is sort of flat on a desk. And then when you draw your z-axis, there's no guidelines for that, but just go straight up the paper. So something like this would be your z-axis. Now, if you've drawn it the way I've drawn it, your x is the diagonal down line, and your y is the diagonal up line, and the z is straight up the page. Let's just make sure that this is correct using the right-hand rule. Okay? So everybody aim your forefinger in the direction of x. Use your right hand. Okay? Aim your forefinger in the direction of x, sort of toward my wall over here. Point your middle finger in the direction of y. That's basically that way ahead of you. Your thumb should be, so forefinger, don't change your forefinger. Forefinger in the direction of x. Keep it. Try to adjust your hand so you don't lose that x, and get your middle finger to point in the direction of y. Okay? Your thumb should be pointing up, or up-ish. Okay? It shouldn't be pointing down-ish, unless you're using the wrong hand. That kind of tells us that the z is up the page. Okay? All right. So this is the vector 2, 3, 4. So how do you plot that? Well, first you need to find a starting point. So I would suggest you use the origin. The origin is, of course, where the three axes meet. So that'll be my initial point here. And then you got to start counting the spaces. Be careful how you count, though. This means delta x. So you're going to count in the direction of x along these hash marks. 2 spaces that way. So you're going to go like this. La-di-da, la-di-da, la-di-da. Stop. Right there. Okay? So you see the green? Okay? Then you're going to go 3 spaces into the y dimension. The y direction is sort of up and to the right. So you're going to go 3 spaces along. You're going to be counting along the grid marks. So you're going to go this way. Right here. You are currently at the point 2, 3 on the xy plane. That's where you are. Okay? Now, to get that z look, you're going to go straight up the paper 4 spaces. But you have to be very careful how you measure the spaces. Mark off your z-axis like this. 1, 2, 3, 4. See how I mark the z-axis? Notice I'm using diagonal tick marks just to match up with the lines on the paper. Take your fingers and go like this. Measure it with your fingers. So put your pencil down. Measure that. Pick up your hand, but don't change it. And put it right on top of 2, 3. Okay, I'll do that again. So to get the upward motion to look perspective correct, what you need to do is measure this with something. Your pencil or your fingers or something. Get this, pick it up off the page, keep them steady, don't move your fingers. Put this right on 2, 3. Looks like we're actually right here. Okay, that's going to draw it on my smart pad here. I'm trying to get this distance 4, see, translated over to here, see. So you got to be real careful with your perspective. It's easy to go too high or too low on that thing. So it's actually right here. That's it. Okay, that thing is 4 units long. How do I know that vertical segment? Because I measured it with this ruler, the Z ruler. So now that's the head of the vector. And I think I'll make my vector red because I used red coloring. This is vector U. Okay? We won't be able to do everything today with 3D, but we can measure how long it is. Okay, so this is delta x, this is delta y, this is delta z. Notice that we're in 3 dimensions now. Words like slope have no meaning. The word slope is totally meaningless. Slope means delta y over delta x, and it means nothing. It doesn't mean anything anymore. Okay? So we're going to stop using the word slope. We're going to start using the phrase directional angles. Okay? If you want to tell me how sloped this thing is, you're going to tell me how many degrees is the red vector from the x-axis, how many degrees is the red vector from the y-axis, and please also tell me how many degrees the red vector is from the z-axis. So you're going to give me 3 angles. They represent how far, like how many degrees away from the 3 axes the red line is. Okay? I'll teach you how to find those 3 angles tomorrow. I'll draw them now, but I'll teach you to find them tomorrow. We're going to find that angle. That's the angle to the x-axis. We're going to find that angle. That's the angle to the y-axis. And we're going to find this angle. That's the angle from the z-axis. And they will be called alpha, beta, and gamma, or the 3 directional angles. But I just wanted to say that slope has no meaning anymore. So we have to have sort of a new system. But today I just want to focus on how would you find the length of such a line? First of all, do you believe it has a length? For sure, right? It has a start and a stop. Is there any reason why mathematically we should be confused here? I mean, shouldn't there have to be some formula for that? I would think so. Okay, so what I'd like you to do is first find this length. That shouldn't be too hard. And see if you can use that blue segment to help you find the red. I'll give you a hint. There's more than one right triangle in this picture. There's definitely more than one right triangle in this picture. So first try to find the blue segment using the dotted greens. That you know how to do. After you know the blue segment, you'll notice it's also part of a right triangle. And you should be able to use the Pythagorean theorem again to get the red. Okay? So I kind of gave it away. Use the Pythagorean theorem to get the blue, then use the Pythagorean theorem again using the blue to get the red. I notice a lot of you guys like to do the square root, you know? Like you'll always do that square root at the end. Is it okay if we just leave our answers as like root 72? Can we do that? Yeah. Okay. So it might be something you decide you want to start doing. Leave your answer as root 72, or if you want to, 6 root 2. But I don't think the decimal is always the best thing to do. Okay, so just bear with me here. We know that this distance is 2 and this distance is 3, so this distance is root 13, correct? But we know that this vertical distance is 4. So the red can be found by just doing the square root of rad 13 squared plus 4 squared. In other words, the square root of what? 29. How many of you got that the magnitude of this 3D vector is root 29? Now, there's a really fast way to get that 29. Look closely with me. What's 2 squared plus 3 squared plus 4 squared? What's 4 plus 9 plus 16? Isn't that faster?
Yes.
Okay, so we have a brand new formula to find the magnitude of a vector ABC. We will simply do square root of a squared plus b squared plus c squared. So this is our new magnitude formula for worksheet 2. It's the same formula as worksheet 1. It just has an extra dimension. So it has this c squared, which wasn't there before. So you could have done this in your head. 4 plus 9 plus 16, and then just slap a square root on it. Okay? So we'll pick it up from there tomorrow. And you can even start the second worksheet, really, if you wanted to. Let's not do it on Monday. Tomorrow I'll show you how to do all these cross products and dot products in 3D.
Are you have a video on this part?
I just recorded that. I can post it. Yeah. In fact, I forgot to stop the recording. We do it now.